Hi everyone, this is part 2 of your midterm to take 2 debrief. This is Miss McConnell.
And Mr. Huff.
So as we were saying last time, if you got imaginary roots in your algebraic factoring, we weren't mad about it. Accidents happen, mistakes happen. But if you got imaginary roots and you showed that you had 4 x-intercepts, or if you got a factor that was, say, like you accidentally put x plus 4 squared, and you didn't have anything in your graph indicating that, that's when we had a problem. Because what you've unfortunately done is you showed that you have absolutely no understanding of how the equation of a polynomial connects to the graph of the polynomial. And unfortunately, that really strongly affected your grades, because if you had made a statement saying, hey, I know that my graph should look like this, but it looks like this in the calculator, and this is how I know it's wrong, that indicates a lot of understanding. Unfortunately, since you had the graphing calculators, Mr. Huff and I had high expectations, and we graded it that way.
Yeah, we were unpleasantly surprised.
Yes, and unless, of course, it looked like you didn't have a graphing calculator, which was really obvious, because this is what you did if you didn't have a graphing calculator. So for minima and maxima, firstly, a lot of students only listed one of the minima or maxima, and
that's the plural form.
Yeah, so
it means more than one.
If I say minima, that implies that we also mean local and global. You have to make sure that you label which is which. And if it says plural, then that implies that you also need to include the local. There's no way to have 2 highest points in the entire graph unless they are exactly equal. Mm-hmm. In which case, you better analyze that a little bit further. So without a graphing calculator is what we are going to focus on. What we would have expected you to do is to just kind of take the middle of the roots that were around it. So if we're looking at this maximum here, then what you would do is you would say that this is like -4 and this is -1.7. So we're looking at about like -2.6 approximately. So if you choose that as your maximum, then you need to have -2.6, and then you need to find out using your equation, what the y coordinate there would be by plugging it in. So you have your q of x equals -x to the 4th. I think it was minus x cubed minus 4. Hold on. Let's see. -x to the 4th minus 4x cubed plus 3x squared plus 12x. Then you can go ahead and find out what q of -2.6 is to figure out what is the output there. Mm-hmm. Yeah. So similarly, you have 0 and 1.7. So you better give me something like about 0.8 for this other maximum. Plug that in. And then you have between 0 and 1.7. So that would have been about -0.8. And then find your y value there. This, of course, is a global maximum because there is absolutely no point that goes above that in the entire graph. Whereas this is a local maximum. Since there are points down here, another common error I saw was listing a minimum as -infinity. That is not...
It's implying that -infinity is a value that you can select, which you cannot.
Right. When you say infinity or -infinity, you're talking about a direction, that it's heading a direction forever. So you can say that this value is a local minimum, but there is no global minimum in this case. Mm-hmm. So then from that, Mr. Huff, do you want to share the intervals of increase and decrease, how you would do that?
Sure. So for intervals of increase, I just need to figure out, well, it's really nice once we have our minimums and maximums. So for intervals of increase, we're basically just trying, as we move through the graph from left to right, we're trying to figure out where the next y value is going to be greater than the previous y value. So at, say, 4, it's 0. And if I move over a little bit to the right, I get an increase in the y value. And so as I keep doing that, that's where it's going to be increasing. It increases until we reach our maximum, after which the y values start to decrease again. So you can almost notate it like something like this. I'll use green. I have had students who just put little pluses around the maximum so that they know that that's plus, and they put little minuses around the other side so that they know that's where the direction changes. And then they do the same thing around the other places. Oh, this is hard to do. Right, so now we have it kind of labeled and marked up, so I know it's increasing from negative infinity all the way to this maximum, so negative 2.6. So increasing from negative infinity to negative 2.6. Now, whether or not you use an inclusive bracket is depending on the way it's been defined. I defined it for my class as being excluded, but if you put an included bracket, I didn't do anything about that necessarily.
But you do need to make sure it's in terms of your x interval, because you're talking about reading the graph from left to right. Mm-hmm. So you're telling the reader in your analysis, on this x interval, that's where
it's increasing,
where my y values. Yeah, when we say it in this context, you're talking about your graph, your y values.
Now, this is the symbol for union. A lot of you didn't use this symbol. It's kind of a weird idea, but it's linking together the two x intervals of increase. And so it basically is signifying that there's an interval of increase, then there's a period of time on the x's where it's not increasing, and then we pick it up again. So now these are all decreasing, so we don't want to use these, but we can then label the next interval of decrease to be from x equals negative 2.6 to be from negative 2.6 to negative 0.8. So an interval of decrease would be from negative 2.6 to negative 0.8. And again, the union tells us that there's going to be a break in those x's. And if we just kind of keep going, now we're on increasing and increasing again. So negative 0.8 to positive 0.8 would be our next interval of increase. And then if we take a look at the graph again, we then switch again to being negative. So now we're decreasing. And so that would be from 0.8 to negative infinity.
Positive infinity.
Sorry, positive infinity.
It's heading towards negative infinity, but that means it's decreasing.
Everything is measured in terms of the x's. Okay. Let's see. So then the y-intercept in this case, we had a root at 0, 0. So the y-intercept would be 0, 0. And then our end behavior as x goes to positive infinity and as x goes to negative infinity, for whatever reason, a lot of people left off one or the other. We want to know what happens to our outputs, and in this case, they both tend to negative infinity.
If you wrote this in words, that was fine. And then some people just wrote left down, right down. I didn't penalize for that because in our activity beforehand, it was written as left down, right down. But the reason it was written like that in the activity is so that you could write the end behavior yourself in what you could call arrow notation. So just a future note, we would like you to write it in arrow notation or verbally in words, or rather written in words is fine. So you could say as x goes to infinity, but left down, right down is not mathematically technical enough for something like this.
Yeah.
Okay. Now this part we are going to cover in a part 3 of the video because we want to make sure that each of these videos aren't getting too long, and then we'll specify what happened with this last problem. See you in the next part.